This is Mr. Anderson for Kellogg Community College, and today we'll be looking over the test review for Chapter 6, and these are some sample problems that could be on the Chapter 6 test. Please make sure to do all of your homework in preparation for this assignment. Okay, so the first problem that we have here is to just simplify the problem and list the restrictions on the domain. Now, the first thing I'm going to do here is take a look at this denominator. And this is a very odd way to write the denominator. Usually we have the powers first and then the everything else second. But you'll notice that this problem is written backwards. So what I'm going to do is fix that by factoring out a -1. If I factor out a -1, the 16 becomes negative and the t squared becomes positive. What this allows me to do is to rewrite the problem as t squared minus 8, the letter t, plus 16 all over, now this problem with -1 factored out in front, t squared minus 16. Now what this is going to allow me to do, it's going to allow me to factor the top and the bottom, find my restrictions on the domain, and then simplify the problem. So my numerator, two numbers to multiply to make 16 and add to make -8, is t minus 4. Now you might be tempted to write t minus 4 quantity squared, but that's not going to help you since you're going to have to do some factoring here. The -1 is still out there in front of this problem, and then we're going to factor this. And two numbers that multiply to make -16 and add to make 0 are t minus 4 and t plus 4. This gives you my -16 and also gives you 0 for the middle term. So what this allows you to do it allows you to do some simplification. Now, first of all, I would say that you should probably get your restrictions on the domain, or as I like to call them, the danger numbers, by setting these two binomials equal to 0. So t is not equal to +4 and t is not equal to -4. And this was a skill that was reviewed in the first section of the Chapter 6 videos that I had to teach. But you would basically go t minus 4 is not equal to 0, and then t plus 4 is not equal to 0. By solving for t in both of these situations, you get the two restrictions on the domain. So these are your two restrictions on the domain, and now we're going to continue to simplify. I don't like you using the word cancel, but these would simplify to make 1 over 1. So here's what we have left. We have t minus 4 over t plus 4. Now you'll notice that that -1 is here in the denominator. It technically needs to go somewhere. So you can put it in parentheses in front of the denominator here, in parentheses in front of the numerator here, or you can put a negative in front of the problem. As long as you have the -1 somewhere in the problem, and we wouldn't actually write the 1 stick here, even though my pen just slipped and that happened. So your answer could be -1 parentheses t minus 4, as long as a -1 is somewhere in the problem. And again, your two restricted values are t is not equal to 4 and t is not equal to -4. So this is your final simplified answer. In problem number 2, since we are working with multiplication, we don't have to worry about silly common denominators or anything. And we also, for this problem, are not going to worry about excluded values. So what we are going to do, though, is do some factoring. So the first, and now I would strongly suggest that you work from left to right in terms of factoring. Now, this first numerator of the first fraction is a SOPs problem, which means that it's a sum of a cubic, which means we can use our pattern for factoring powers of 3. So the cubic root of 27x cubed is 3x. The cubic root of 8y cubed is 2y. And then we are going to take our trinomial. Now again, this is still just this first part right here. And this is going to be then the square of 3x squared, which is 9x squared. And then we have the opposite product of 3 and 2, which is -6, and then xy. And then the square of 2y, which is going to be 4y squared. All right, sorry, that got a little small there. Okay, now what I'm going to do is work on this bottom one, and I will change pen colors here, just to kind of keep things straight. Okay, so now I'm working on this fraction here. I'm going to factor out a 5, and if I factor out a 5, that gives me x squared minus y squared, which I can factor that into x plus y and x minus y. Because if I factor out the 5, this gives me a difference of squares, x plus y, x minus y. Okay, now what I'm going to do is go to my next color here and work on the third part of the problem here. So I'm looking at this, and it's factorable. It's x squared minus 2xy plus y squared, or what number multiplies to make 1 and adds to make negative 2, and that is going to be x minus y written twice. Because these two negative y and negative y multiply to make positive y squared, and the negative xy and negative xy add to make the 2xy. Now you might sweat a little bit when looking at this problem here as to, oh my gosh, it's a tricky trinomial, but instead what you'll notice that if you look at the blue on the screen here, you'll notice that that is actually one of the trinomials here that we have left over from the SOPS problem. So I'm going to color this blue because it will simplify with this blue up here on top. Now it would probably make a little bit more sense if you'll notice that I haven't put in my symbols yet. The symbols of the division bars and the multiplication symbol here. But you'll notice that this is a division sign. So our obvious step right here is to skip, flip, and multiply. So we're going to multiply instead of divide. The numerator is now 10x plus, or 10x minus 15y, and the denominator is now 6x plus 4y. Now let me go to some new colors here. Wait, wrong color. Hold on. There we go. What I'm going to do is now factor out, I'm going to kind of focus on this flipped denominator here. The number that goes in evenly into 10 and 15 is 5. And that is going to leave me with 2x minus 3y. And then I'm going to look at the bottom here, changing colors one last time. And this is going to be 6x plus 4y. And this is going to be, then I'm going to factor out a 2. And that will leave me with 3x plus 2y. Alright, so now what I'm going to do, go back to my black pen here, and I'm going to now do some simplification, or as people like to say, cancellation, but it's really simplifying because this binomial divided by this binomial is 1 over 1. And then we have this 3x plus 2y, blue and red, they go away. And this trinomial from the SOPs simplifies with that trinomial there. So, gosh, it looks like there's one thing left. The 5s also simplify. So what that leaves me with is this green and kind of purple right here. So this is going to be x minus y. And this is going to be 2x minus 3y. And then over, let's go down here. This is going to be my x plus y and the 2 from the last fraction. There is nothing else to simplify because we have to have perfect binomials to simplify with each other. Now, after a long problem like that, it's probably nice to take a little bit of a mental break, and if you look at number 3, since these are common denominators, you would just put the 2 together. So you'd have x cubed plus 4x over x plus 2. Now I changed the order now because I like to have my cubes in front. You may want to check here and on the test to see if you can factor something out, which you can do in x here. And this gives you x squared plus 4. Now, what's important about that is you'll notice that x squared plus 4 is not further factorable. It's not further factorable because it's not a difference of squares. If this is a minus, then we could make this x plus 2x minus 2, and you could simplify the x plus 2's. So, look for things like that on the test if you can go a step beyond. But this is your answer for this problem, but that's not to say that things won't be a little bit more difficult or a little bit more involved on the test. All right, to round out the first page, we're going to take a look at problem number 4. Now, you'll notice that the denominators aren't the same, and since the denominators are not the same, we have to get them to be the same, but we're really close. So instead of trying to multiply both sides by an a minus b, let's take a look at the second part of problem 4. You'll notice that this is just written in the opposite order. So if I factor out a negative 1, what that gives me is negative b plus a, which I can rewrite as a minus b. So as long as I factor out a negative 1, I can switch the order of the denominator. And this is a pretty powerful trick because what I can then do is write the numerator as 7 on the right-hand side here. I can write that as negative 1, and then this is multiplied by negative 7b squared plus 14ab all over a minus b. Now you'll notice that the negative 1 floated up to the top, which you can do that. As I explained in problem number 1, the negative 1 can go top, bottom, or in the middle. But this is where it's going to go because we're going to need to distribute that through everything here. I think some of you also remember a shortcut where I said you can switch the denominator if you switch the operation symbol, which would have changed this into a subtraction sign, and that would have had the same effect. So our numerator now combined is 7a squared plus 7b minus 14 AB. Now, you'll notice that things are kind of written out of order here, and I'm going to spend some time to try to fix that mistake. So let's go change the order here. And at the same time, let's factor out a 7, because I notice that the 7s are in common with all three parts of the numerator. So 7, and then this is going to be a squared minus 2ab plus just b, all over a minus b. So what this means is I can take this and probably do some factoring. What two numbers multiply to make 1 and add to make negative 2? And we've had that problem before. That was actually very similar to what we had in problem 2 in that second fraction. In this case, the answer is going to be a minus b, a minus b. And that's because you have negative b and negative b make a total of b squared. I keep forgetting that b squared that should be there. And then if I take a negative ab and negative ab, it gives me a negative 2ab, all over a minus b. And this is where I can simplify these two. So my answer to the problem is just 7 times a minus b. There's no need to put that back in, but if you wrote your answer as 7a minus 7b, I wouldn't be upset about that. And so that's problem number 4 and the first page of the test here.